Hello, guys. Welcome to Academic World by Patella TL. Now we have got interesting stuff here. We are looking at question 5, and believe you me, this is the question 5 of a certain previous question paper. I don't know which question paper it is, to be honest with you, because I just collected the previous papers, especially functions. So we're going to deal a lot with previous question papers of functions. Okay, so now without waste of time, let's go through this previous question paper here. Question 5, I'm dealing with functions. So question 5 says, the diagram below shows the graph of g of x. So they say what you see down there is the graph of g of x. Let me try to pick a different pen. Yes. The diagram below shows the graph of g of x. So this is actually the equation g of x, the function g of x. But they are saying the diagram below shows the graph of g of x. Can we see the graph of g of x? It is easy to notice that the graph of g is this one here. So it means you see GG here. So these are the two graphs, actually not two graphs, actually this represents the hyperbola graph. You can see the graph of G. Let me mess it up with a red color. So this is a graph of G. This is the graph of G, represented by the red color in this case. And what type of a graph is this graph of G? It's a hyperbola graph. Because we can even see from the equation of G, they say G of x equals to 2 over x plus p plus q. And I told you that as long as x is the denominator, that function that you are looking at is a hyperbola function. So I have a hyperbola function equation. This is the equation of the hyperbola function, but it's incomplete. Why am I saying this equation of a hyperbola function is incomplete? Because we are missing the value of p and q. You can see by merely looking at the equation g of x equals to 2 over x plus p plus q, you can see that the variable p and q is missing on that equation. So I'm saying, okay, this is the equation of g, which is incomplete. But now here, this is g on the graph. This is g on the graph. So we have got g as an equation and g represented in terms of a graph, which is a hyperbola function. Now, and they are saying, and we have f of x. So we have got two functions on the same plane. Typical exam question. This is what they do in your exam, guys. They normally bring two functions together. So in this case, they brought g of x, which is a hyperbola function, and they brought f of x. Which function is f of x? This is a logarithm function. This one is a logarithm. You can see it is written in a log form there. It's a logarithm, and let me tell you, the logarithm function, it is actually the inverse of the exponential function. So they gave us f of x equals to log x base 3. So they gave us the function f in a log form. And they actually, when they give you a function in a log form, just know that you can be able to write it right away in the exponential form. What is log can be written in an exponential form. How can we write this f of x equals to log x base 3? In exponential form is x. It's x equals to 3 to the exponent 1. So this one and this one is the same thing. Oh, guys, I wish you understand here. I'm saying the logarithm function f of x equals to log x base 3 can be written in exponential way. It's the same expression, but we can write it differently. We can write it in the exponential form. Actually, myself, when I'm dealing with this kind of a function, I normally prefer to take it from a log form right away and put it in the exponential form and claim that the two guys is one thing. This is this. And pay attention to details. Be very careful. I'm not saying f of x equals to log x base 3 if inverse is x equals to 3 to the exponent 1. No. This is not x equals to 3 to the exponent y is not the inverse of this f of x. It's actually the same thing written differently. No? Okay. Now, I have g is hyperbola. I have f is exponential. I love this one actually because they brought these two functions together. I love this one. Why? Because they brought two functions together, which both of them, they have got the asymptote. Sorry. The hyperbola function, let me go to the other side a bit. There are the questions. Yeah, I want to write here. The hyperbola function and the exponential function In this case, remember the exponential is the inverse of log. So log and exponential, they have a tendency of behaving the same way. So the hyperbola function and the exponential function, or maybe the logarithm function, now they have got something in common. They both have what we call the asymptote. That's the first thing that I want us to highlight. The hyperbola function has got the asymptote. The hyperbola function has got the two asymptotes. It has got the x asymptote. I'm just reminding you key stuff here. It has the x asymptote, which is a vertical asymptote. And it also has the y asymptote. Which is a horizontal asymptote. So the hyperbola function has got two asymptotes. But when you look at the exponential function and the log function, they have got only one asymptote, and that is the asymptote of y. So exponential function has got the y asymptote. Actually, in this video lesson, I want to relax and explain to you this mathematical ideas. Because most of the time, teachers, we've got a tendency of rushing through. Maybe we focus on covering the syllabus. But here, I want to make sure that you get mathematical ideas. You have a concrete mathematical knowledge. That's what I want to impart in you guys. So I'm saying the hyperbola function has got two asymptotes. It has got the x asymptote, which is a vertical asymptote. And it has also got the y asymptote, which is a horizontal asymptote. That is a hyperbola function for you. Exponential, only one asymptote, and that is the asymptote of y. Now, I hate talking about things that are not sense-making. So we have to make sense a bit. What are we talking about when we talk about the x asymptote? Okay, so actually, I'm also repetitive in my explanation because these things, I think I'm explaining them repetitively because it's so important for you to understand these ideas. So I don't mind repeating this idea. The x asymptote, what is it? The x asymptote is that value of x whereby we cannot find the value of y. For that value of x, we cannot be able to calculate the value of y. Let me give you with y equals to a simple example. Y equals to 2 over x minus 1. Now, if you look at y equals to 2 over x minus 1, when the value of x it is 2, it's easy to find the value of y. What is y? Y is going to be 2 over, where there is x we put 2. So it's going to be 2 minus 1. So what is y? Is 2 over 2 minus 1 is 1. So the value of y, it is 2. So we are saying when x is 2, for this function, you can also call it f of x equals to 2 by x minus 1. Instead of saying y, you can say f of x. So for this function, when x is 2, the value of y is 2. But now, let's try to calculate the value of y when x is 1. I'm going to erase here. Eraser. Okay. Welcome to Academic World by Partiality L. This is where we make mathematics to be interesting. Now, let's find when x is 1, using this equation, let us find y. So we say y equals to 2 over x is 1. So we say 1 minus 1. So y equals to 2 over 0, which is undefined. Any number divided by 0 is undefined. So we see that when x is 1, we cannot find the value of y. So we say it means that for this function, which is 2 over x minus 1, this x being 1, it is the x asymptote. Is that value of x which we cannot use to find the y value. Is the input that cannot give us the output value. So then we say, oh, x being 1 is the x asymptote. So what is the y asymptote? The value of y which does not have any x mapping with it. Okay? So for example, let me just say the value of y where you cannot find the value of x for simplicity. You now know what is the asymptote. What is the x asymptote and what is the y asymptote? So I'm saying hyperbola function has got both these asymptotes, x and y. Exponential function has got only the y asymptote. Let me go back to the problem and explain why I talked about this. Yeah, this is the question we are looking at. Y equals to negative 1 is the horizontal asymptote of G. So you see this asymptote here. We see that is the horizontal asymptote, which is the y asymptote. This is the y asymptote. The horizontal asymptote is the asymptote of y. So we have got the y asymptote. But it's very important now to know that this asymptote belongs to which function? Because I'm having two functions here. I'm having the hyperbola function and the exponential function brought together. On question 5, they are together. And I see the horizontal asymptote y equals to negative 1, which is the y asymptote. And both of these two functions, the hyperbola function has got the y asymptote, and the exponential function, or you can call it log function in this form, it has got the y asymptote. So it's important to know that this y equals to negative 1, which is the asymptote after all, it's important to know that is the asymptote of which function? Is it the asymptote of hyperbola? Is it the asymptote of exponential? Here, if we look at our first bullet, they are saying y equals to negative 1 is the horizontal asymptote of G. So this guy is explaining or is giving clearly that this asymptote is the asymptote of the function g. So y equals to -1 is the asymptote of a function g. So we know to which function this asymptote belongs to. Y equals to -1 is the y asymptote of hyperbola, because g is our hyperbola function. So this asymptote here, this horizontal asymptote, y equals to -1, in this case, is the asymptote of hyperbola. It was very important because even the exponential function, it has got this kind of asymptote. Okay, but now I see why we can't even be confused. Let me teach my math very well. If you look at the function f, now I have to teach math. If you look at the function f, let me use the blue color here to highlight this function f. It's going like this. Okay, so this is a logarithm function. It's a logarithm actually. It's not exponential. It's a logarithm function. Okay, which is the inverse of exponential function. The log function is the inverse of the exponential function. But now, I said to you, the exponential function has got the y asymptote. Can I go to that page? I said the exponential function has got the y asymptote. Now, the inverse, this one I think it's very important. The inverse of the exponential, which is the logarithm function, it has got only one asymptote, and that is the x asymptote. Okay? That is the x asymptote. Actually, okay, it means that this function f, it cannot, this one is not going to have the horizontal asymptote. I'm sorry guys if I said this function f will have the horizontal asymptote, because it's a hyperbola, I mean it's the logarithm function. It's a log function. It's not the exponential. So its asymptote is going to be the x asymptote, which is a vertical asymptote. Surprisingly, I don't see that asymptote here on the Cartesian plane. Don't worry, we are learning math. We will make math to be simple. Don't worry. I'm saying this function f, the logarithm, has got the x asymptote, this function f. So where is its asymptote? Because I see the x asymptote here, this x asymptote here, I'm showing it with the red color. This x asymptote here, can it be the x asymptote of this log function? The answer is no. Why? Because the log function f is passing through this asymptote. It's cutting this asymptote. So this is not the asymptote of f. If this was the asymptote of f, f was not going to touch this asymptote. So obviously, this vertical asymptote here is the asymptote of g. Remember, I said this function g should have both the horizontal asymptote and the vertical asymptote, because the function g is the hyperbola. It has got both these asymptotes. Now, a log function, it has got only one asymptote, the asymptote of x. And where is that asymptote? It appears as if they did not show us the asymptote, but guys, it is there. Why am I saying this logarithm function has got the x asymptote? It is there. Where is it? You don't see it, but we can see very carefully that this function f, I'm highlighting with the red color, does not touch the y-axis. So the asymptote is actually exactly on this y-axis. Wow. So it has got the asymptote. It has got the vertical asymptote. The vertical asymptote, and the equation of that vertical asymptote, it is x equals to 0. Because here on the origin we have 0. And we see that this vertical asymptote pass where x is 0. So, guys, let me raise again. This is very, very important. This is very, very, very important. Look on the Cartesian plane. You see the function f is not touching the y-axis. It actually should not touch the y-axis. You see, it's just approaching, it's getting closer. It's not touching. If you think it's touching, it's not. So there is an asymptote here on this line, which is called the vertical asymptote. So that the logarithm function has got only one asymptote, which is the asymptote of x. Whereas the exponential function has got one asymptote, which is the asymptote of y. Okay, so I think that one is explained as well. Now b, 1 and 0 is the x-intercept of f. So now they are saying the point b, it is the x-intercept of f. You see the point b. This is the x-intercept of f. So says the examiner. Another thing that I want to teach you is to understand the language of maths. Make sure that you are understanding the mathematical language, because understanding the language that we speak as mathematicians will help you in improving in your maths. So they are saying B is the x-intercept of f. You must understand what they are talking about. They are simply saying f cut the x-axis. It passed the x-axis at B. So that is why they say B is the x-intercept of f. Remember, the x-intercept should be seated on the x-axis. If a point is not on the x-axis, cannot be called the x-intercept. Only those points that are on the x-axis, they are considered to be the x-intercept. And what is this x-intercept? It is the x-cut of the graph. So we are saying the function f, this logarithm function f, is cut the x-axis at the point B. Okay, welcome. Hopefully you are learning. I'm enjoying this function topic. Oh, and it's coming in your final exam. It's obvious. Once you get these mathematical ideas, especially for functions, I'm telling you it's a pass. So B is the x-intercept of f, meaning the function f cuts the x-axis at B. I'm not surprised why it is 0 there. Why it is 0 there? Because at the x-intercept, the value of y is always 0. Or on any point on the x-axis, y will be 0. Okay, so this part we talked about is the x-intercept of f. And now you look at G. G should also have its own x-intercept. They did not specify which point is the x-intercept of G, but it's here. This is where the function G cuts the x-axis. So both functions have got their x-intercept. F has got the x-intercept at B. G has got the x-intercept on a point which is not being specified. So maybe the examiner says, I'm not going to put my focus there when I ask you questions. Maybe, okay? Now let's go to A. A, which is T and 1. So on the point A, T and Y, they are denying us the x-coordinate. So you look at A, they are saying the x-coordinate we are not giving you. It's just T. But what is the y-coordinate? They are saying it's 1. So A, it has got A is made up of T and 1. So actually the point A here. Oh, I think he will say it's the point of intersection because it's where F and G intersect. A, T and 1 is the point of intersection. Wow. Wow. We have got the point of intersection here. This is interesting math. I love this math. I love this one. The point of intersection. The point of intersection, meaning the point where the two graphs meet. Where do they meet? They meet at this point A, which is T and 1. So the point of intersection, guys, is very, 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 very important in math. You must be exposed to the idea of the point of intersection. Okay, let me go to somewhere where I can talk, I can explain a bit more about the point of intersection. I just want to teach maths, the point of intersection. I have to give you information about this point. You need to be more informed about the point of intersection because it's a typical exam-related idea. Anytime is tea time, we can ask you about the point of intersection. The point of intersection. What is the point of intersection? Point of intersection. Okay, in that case, it was the point A. Okay, so let's say we have got the y-axis and the x-axis. Now we have got two graphs. Let me say I have a graph which is a quadratic function, which is my shape. And I have another graph, let me say in this case it's a straight line. So let me call the quadratic F. Let me call the straight line G. Now you can see that F and G, they have got this point here where they intersect. So this is my point of intersection. Now, how can I find the coordinates of this point of intersection? Let's say suppose they ask me to find the coordinates of the point of intersection. Let's say maybe they've given me the function f. They are saying f of x is equals to x squared minus 4. Actually, this graph of f of x, this question cannot be x squared minus 4. But I'm saying suppose, don't worry, because I just want to explain the point of intersection. Suppose f of x, its equation is x squared minus 4. And suppose g of x, its equation is x plus 1. Okay, suppose, I'm just saying suppose. Now I want to know the point of intersection. How am I going to find the point of intersection? Because this point of intersection is where the 2-point graph, it's where the two graphs meet. They intersect at this point of intersection. They meet at this point. So to find the coordinates of this point, I'm going to equate the equations of the two graphs. What is the equation of f in this case? Is x squared minus 4. So I'm going to take this x squared minus 4, equate it to what? To the equation of g. What is the equation of g? X plus 1. So by equating the two equations, I'm looking for the point of intersection. How do we find the point of intersection? Ladies and gentlemen, we equate the two equations. So we say x squared minus 4 equals to x plus 1. Why do we equate the two equations? Because that's where the two graphs meet. And that point is called the point of intersection. So how do we find the point of intersection? By equating the two equations of those two graphs that meet. So now let's go back to our question here to the examiner. He's giving us the point A. He's saying this is where F meets with G. But in this case, this examiner gave us the Y coordinate. So if he will ask us to find anything here, he might want to know the X coordinate. He might want to know the value of T. Okay? Okay. Interesting. Interesting. Let's go through this. You see, I'm not rushing to go and answer the questions because I want you to be informed. I want you to be imparted with mathematical knowledge. I'm giving you ideas in mathematics. Okay. Now, the vertical asymptote of G intersect the x-axis at E. Yes. The vertical asymptote of G is here. It intersects the x-axis at E. It passes here at E. And we are not given any x value at E. So we don't know the vertical asymptote of G. We know the horizontal asymptote. It is y equals to -1. But at E, this guy didn't tell us anything about, oops, sorry. He didn't tell us anything about the point E. He didn't give us any value there at E. Had he said at E, if he said E maybe it's 4 here, we were going to know that the equation of the vertical asymptote is x equals to 4. So we are given only the equation of this one, of the horizontal, y equals to -1. But we don't have the equation of the vertical asymptote. Both this one and this one, they are the asymptote of G. So we are only given the horizontal asymptote of G. We don't have the vertical asymptote of G. Maybe also he will want us to find this vertical asymptote of G. Okay? Now he's saying OB. Now in math, if I say OB, I'm referring to the length OB. I'm referring for the distance from O to B. So when I say OB equals to BE, I'm saying the distance of OB is the same as the distance of BE. So let us look at OB. OB, I'm going to show this distance of OB. Firstly, let me erase everything. I'm going to show the distance of OB with a red color. This is OB, is referring to this one. Yes. Okay. This is OB. And do you know what is the distance from O to B? It is 1. Because you see at B, the x coordinate is 1. So it means from 0 to B, it's 1. Even if you use the distance formula, you realize that the length of OB is 1. Now, and it means that even the length from B to E should be 1. Because he's saying OB equals to BE. So the distance, again, the length from B to E also should be 1. So the distance from B to E also here should be 1. Which means that from O to E, it is 2 units. So E, it is 2. So at this E, so now I know the vertical asymptote, x equals to 2. Because the vertical asymptote passes at E, which is 2 units from O. That is why Charlie was telling that the OB and BE. He wanted us to know that at E, the x value there at E, it is 2. Now I have got both asymptotes of G, the horizontal, and the vertical asymptote. Okay, I think now we are ready to go and look at the question. Let me have a bit of a sip of a drink, because talking, guys, is exhausting. So I normally prefer to have something to drink, either water or tea or something. Okay, so in this case, is called t, because I was talking, and then it, yeah. So, okay, write down the range of g. Let's look at g. Oh, we remember that g is a hyperbola. If you remember, g, it is a hyperbola function. 2 marks. Now we are in the exam. I want to show you how we get easy marks in the exam. And first questions are always simple to approach. They are easy, simple to approach. Yeah. Okay. First questions are always easy to approach. So they want the range of g. I remember very well g is a hyperbola function. So let us go to g. This function g here. What is its range? Now, we know that when we are looking for the range of a hyperbola function, it's very simple. When the range of a hyperbola function is simple, you just say y is any real number. Y is the element of real number. But y should not be the horizontal asymptote. Y can be anything, but y should not be the y asymptote. Do we know the y asymptote? Oh yes, it is here. Remember, this y equals to -1 is the horizontal asymptote of g. It is the asymptote of g. So we say y can be any real number, y should not be -1. So this is the range of a function g. So finding the range of a hyperbola function, guys, is simple, very simple. What do? You say y is the element of real numbers. Y can be any number, but we know that y should not be the y asymptote. So what is the y asymptote? We are referring to the horizontal asymptote. Again, let's go back. What is the horizontal asymptote? This line here, which is -1. So y should not be -1. Let me give you 2 marks. Let me bless you with 2 marks. 1, 2. Okay. Now, second question. Okay, this guy now wanted the range of g, but what if he wanted the domain? Next time he might want the domain. Let's not do Kremlin. So the domain is going to be, we say x can be any real number. X can be any real number, but x should not be the x asymptote. So you have to know the x asymptote. In this case, the x asymptote, I said it is 2. The equation of this asymptote is x equals 2. So the domain was going to be x can be any real number, but x should not be 2. So x can be any number, but x should not be the x asymptote. Okay, let's go to the second question. Determine the equation of g. What is the equation of g? I told you that the function g is incomplete. We must know p and we must know q. I love this one. Ooh, I love this question 5. I love this question 5. So, okay, what's happening? I'm here. Okay, yes. If you remember the equation of g, the incomplete one is g of x equals to 2 over x plus p plus q. So to find the equation of g in this case, we just have to know p and q. No wonder it is 2 marks. We just need to know the value of p and the value of q. Then we will know the equation of g. Now, what will be the value of p? I'm going to put this positive sign here between x plus p with a rate. I'm going to circle it with rate. What does it imply? When you have x plus p, from this equation is positive sign, it means that p is going to be negative of the x asymptote. Yes, P is going to be the negative of the x. Let me not say negative. Let me say P will have the sign which is different to the x asymptote. If the x asymptote is free, P is going to be negative 3. If the x asymptote it is negative 3, P is going to be 3. So watch out for this positive sign here. When we give you the incomplete equation, which is 2 over, focus on the denominator, x plus P. As long as between x and P is a positive sign, it means that P is going to be the same value of the x asymptote but of a different sign. So I'm going to look for the x asymptote on the graph. So let me go to the graph. What is the x asymptote? It is this 2. The x asymptote, it is 2 here. It's x equals to 2. Hopefully you still remember how I found this x asymptote. You have to find it. It was not given x equals to 2. Okay, so because the x asymptote it is 2, it means that P will have a different sign to the x asymptote. The x asymptote is positive, therefore P is going to be negative. P is negative 2. So I already know the value of P now. I know the value of P, so I have to know the value. But Q is simple because this Q here, from this incomplete equation, this Q, let us look at G of x equals to 2 over x plus P plus 2. This Q here represents the horizontal asymptote. The horizontal asymptote. So what is the horizontal asymptote? It is negative 1. So it means that Q is equals to negative 1. Okay? Yes. Q is equals to negative 1. So I have P, I have Q. Now I know the equation of G. It means the equation of G is going to be 2 over x plus, we found P to be negative 2. This P here, we said is negative 2. Negative 2 plus, we found this Q to be negative 1. So it means the equation of G is 2 over x minus 2 minus 1. Let me write it here. The equation of G the equation of G is 2 over x minus 2 minus 1. We still bless you with 2 marks if you found this one. So now we are going to 5.3, which is calculate the value of t. Calculate the value of t. Let us look at which t they are talking about. They are referring to this t here. At the point of intersection, remember the point A, which is the point of intersection, they are saying is t and 1. So they want to know the t actual. They want to know the value of t. And if you look at this point A, it lies on both functions. It lies on G. G pass on the point A, F pass on the point A. So we can use both G and F to find the coordinates of a point A. Wow. I love this one. I love this one. So I'm going to start with the approach that I don't want us to use. Okay, let me go to the approach which I want you to do. The approach which I want you to go for. You have f of x equals to log x base of 3. You have f of x equals to log x base of 3. So the function f pass at a, and we know that at a, the y value it is 1. So we're going to find x when y is 1. Our x in this case is t. So it's okay. I'm going to use f of x. I can use f, I can use g, because both they pass at the point a. So now if I'm using a logarithm function to find t in this case, I will say, okay, let me try to write this log function in exponential form first, because it is easier to work with it when it is in the exponential form. So I'm going to say, okay, this in the exponential form, y becomes x. The base does not change, x becomes 1. So this is the same as x equals to 3 to the exponent 1. And I'm told that at a, t, x is t, y is 1. So I can find the x coordinate by substituting y with 1. So I'm going to say x equals to 3, y I'm going to substitute it with 1. So x equals to 3 to the exponent 1, which is x equals to 3. So this x, so the coordinate of a is 3 and 1. It means t is 3. So t is 3. We were answering this question here. So let me write it down here. It was g of x equals to log x base 3. So what you can do, you say x equals to 3 to the exponent y. Let me say 1. And then x equals to 3 to the exponent 1. Y, remember I said it's 1. We are calculating x when y is 1. Another mark. Then t equals to 3. I believe something like this. 3 marks. Actually, I was wondering how they give you this 3 marks. Now we are going to 5.4, which is to write down the equation of the inverse. I love this one. They love this kind of question. The equation of the inverse. The inverse of what? Of f. So write down the equation of the inverse of f in the form y equals to. So the first thing that we're going to do, we're going to write this function f down. Let's write the function f down. What is f? F of x equals to log of x base 3. Let me show it here. This is f. F equals to log x base 3. Here it is. Now they want the inverse of f. Okay. Now before you find the inverse of this function, write it in the exponential form, because this is in a log. Just change it to the exponential form. You say when there is y, you put x. X equals to 3 to the exponent 1. So we say this one and this one is the same thing. So looking for the inverse of f of x equals to log x base 3 is the same as looking for the inverse of x equals to 3 to the exponent 1. So what is the inverse of this x equals to 3 to the exponent 1? Now, I'm looking for the inverse of this function. X equals to 3 to the exponent 1. Why looking for the inverse of the function x equals to 3 to the exponent 1? Because x equals to 3 to the exponent 1 is the same as f of x equals to log x base 3. It's just written in different way, but it's the same thing. So what is the inverse of x equals to 3 to the exponent 1? When you're looking for the inverse of a function, you swap those functions. So you're going to say y equals to 3 to the exponent x. So this is the inverse of a function f. Y equals to 3 to the exponent x. We give you 2 marks as well, if you like. Now here they are saying, for which values of x will the inverse be below 3? for which values of x will the inverse be below 3? Now, this kind of questions, they are normally, they can be easily answered with the aid of diagram. Yes. With the aid of diagram, we can be able to solve this problem. So they are looking for which values of x will the inverse be below 3. So let me say, okay, let me sketch the function, let me visualize the inverse function in terms of a graph. I want it in terms of a graph. How will it look like on the graph? The inverse of a function. Remember, this is the function f. This one here, let me erase everything. Hopefully you are learning. Hopefully you are learning. Because I can see this question has got, this question is so very, very, very interesting. Okay, the coordinates of A, you still remember I said it's 3 and 1. That will be important. Now, this is the function f here. We can try to put the inverse of a function here. We can try to sketch it so that we'll be able to solve the problem. And you'll be surprised when we sketch the inverse f, it's going to be simple. Don't think it's going to be difficult. What we are going to do, we're going to say, okay, on the function f, we had a point A which is 3 and 1. It means on the inverse, we are going to have a point which is 1 and 3. So let us put the point 1 and 3 here. 1, already it's 1. So where can it be 3? X is 1, so 2 and 1, 2, 3. Let's say 1 and 3 will be here. So you see, if a point, if on the point F we have 3 and 1, it means that on the one of the points of the inverse, it's 1 and 3. You just swap those coordinates. Another point that I see, it's 1 and 0 on F. So once you have 1 and 0 on F, it means on the inverse, you're going to have 0 and 1. So 0 and 1, where can it be? X is 0 on the y-axis. Or it can be here. So you notice that your graph actually goes like this. It goes from this point. And remember now, what was the asymptote of this hyperbola function f? What was the asymptote? X equals to 0. It means now, okay, let me write it this time. The asymptote of the function f, which was log, it was a vertical asymptote. It was x equals to 0. So the asymptote of the inverse now is going to be y equals to 0. So we have the asymptote somewhere here on the x-axis. So it's going to be here. The function is like this. So now they are saying, for which values of x is the inverse below 3? So let us go to where y is 3. Y is 3 at this point. This point is 1 and 3. This is where y is 3. Let me just say, let me draw this line coming this way. This is the line where y is 3. Now they are saying, for which values of x will the inverse be below 3? We see that the inverse is below 3. This is the portion of the inverse which is below 3, this part. That other one is on top. This is the portion which is below 3. This is from this point going to the left. So it means when x is less than 1. So when x is less than 1, the inverse of f is below 3. Yes. So it is when x is less than 1. When x is less than 1, we give you 2 marks. Now they say, determine the point of intersection of the graph of f and the axis of symmetry of G that has a negative gradient. I love these questions, guys. I love this question. This is a very good, the examiner here is doing a very good job. This is a good way to ask mathematical questions. Now here, they are saying, determine the point of the intersection of the graph of f. And I told you, how do we find the point of intersection? No, I said we equate the two graphs, the two equations of those two graphs. So I'm answering 5.6. Wow, this is good. This is good. I'm going to raise here. I'm going to show my working here on top of 5.6. So I'm going to say, okay, determine the point of intersection of the graph of f. So do we know the equation of f? What is the equation of f? The equation of f is log x base 3. That is the equation of f. Log x base 3, which you can right away write it in terms of x equals to 3 to the exponent 1. To make it to be more easier, write it in the exponential format. X equals to 3 to the exponent 1. Now, they say determine the point of intersection of the graph of f and the axis of symmetry of G. G is a hyperbola function. Remember, in my lessons, I told you that the hyperbola function has got the axis of symmetry. So now they want to know the point of intersection of this function f and the axis of symmetry of G that has a negative gradient. It means we still have to find the axis of symmetry first. The axis of symmetry. We have to find the axis of symmetry of G. What is the function G? The function G, if I still remember, is, what was the equation of G? It was 2 over x minus 2 minus 1. Let me make sure. Yes. So is g of x equals to 2 over x minus 2 minus 1. So we have to find the axis of symmetry of this G. Now I will show you the easier method of finding the axis of symmetry of G. If you are in the exam, you can go for the easy approach, as long as you get the job done. So you're going to focus here. You see this part which I've somehow enclosed with the red color ink there. I'm going to focus there. I'm going to say g of x is my y equals to this denominator. I'm going to multiply it by negative. So it was x is going to be negative x. If negative 2 is going to be positive 2. So I multiply this part, x minus 2 by negative. This one, just take it as it is, minus 1. So y equals to minus x plus 1. So this is the equation of the axis of symmetry of G. So they want to know, where does this x equals to 3 to the exponent y and y equals to negative x plus 1 meet? What is their point of intersection? So now you can solve this simultaneously as well. If you can't equate the two equations, you can solve them simultaneously. You can say x equals to 3 to the exponent y is equation 1. Y equals to negative x plus 1 is equation 2. Another way of finding the point of intersection of two equations is by using simultaneous equation. So now I'm going to substitute equation 2 on equation 1. Okay, or which one should I substitute? Yeah, I'm going to substitute equation 2 on equation 1. But something is tricky here. Now I'm going to say, okay, x equals to, which one should I substitute? I need to be careful. Or should I substitute 1 into 2? It's going to be y equals to minus 3 to the exponent 1 plus 1. Yes, I have got two equations and they are ugly equations. One is the exponential form, one is a straight line. And you look at these two equations. Okay, let me show you why I'm saying they are ugly equations. Maybe if I show workings, you'll understand where I'm coming from. They're saying x equals to 3 to the exponent 1. We can substitute 2 in 1, or we can substitute 1 in 2. So I'm looking here on which one actually is the easier approach. Let me substitute 2 in 1. So I'm going to have x equals to 3 on equation 1, where there is y, I'm putting negative x plus 1. So x equals to 3 to the exponent negative x plus 1, which it will not be easy to solve for x here. Remember? Okay, so let me do it vice versa. Let me substitute equation 1 on 2. So I'm going to say y equals to x is going to be 3 to the exponent 1. So minus 3 to the exponent y plus 1, which is the same as y. Okay, let me say 3 to the exponent y equals to 1 minus y. So 3 to the exponent y equals to 1 minus y. So when you solve this simultaneously, you obtain very ugly equation. I think something says that maybe we have to use it in terms of we have to take the graph form approach. Maybe we should also put these things on sketch and see where they can intersect. Because I'm having an ugly equation. 3 to the, if I was to solve here, I was going to try this one. 3 to the exponent y equals to 1 minus y. So, oh, why it is 0? Because, yeah, this is maths for you. You have 3 to the exponent y equals to 1 minus y. And you want to solve for x. For sure you understand why this is an ugly equation. Y is the exponent there on 3. Then we have got here y is the exponent. Here y is just, it's not in an exponent form. So it's very tricky. So how do you solve for y here? Which approach do you use? It's very tricky. So we want the value of y whereby the left hand side will be equal to the right hand side. And I see that y, it is 0. Because if y is 0, if I put 0 on the left, I'm going to have 3 to the exponent 0. And if I put y on, 0 on the right, I'm claiming that my y is 0. 1 minus 0. So 3 to the exponent 1 is 1. So 1 equals to 1. So the value, the two functions, the axis of symmetry and also the function f, they meet where y it is 0. So, okay, we know y it is 0. How can we solve for x? We go to any of the two equations. So you can go to x equals to 3 to the exponent y, x equals to, okay, you can say from x equals to 3 to the exponent y, your y is 0. So x equals to 3 to the exponent 0, therefore x is 1. So the intersection point, yeah, this is a very cruel question. The intersection point, it is 1 and 0. It's not that simultaneous equation that you can solve so easy. Create equation 1, create equation 2, create equation 3, and suddenly you are getting your answer. When we substitute 1 into 2 or 2 into 1, the equation becomes very ugly. We have an ugly equation, so which cannot, it's not that easy to spot this one. Okay, so let me just summarize what I was saying here, actually, because I have to be honest, this is very tricky. It's very tricky. I'm having two equations, and I want to know their point of intersection. I have the axis of symmetry of G, which is y equals to negative x plus 1. And I have another function, which is function f. I wrote it in the exponential form, x equals to 3 to the exponent 1. So I want to solve these two equations simultaneously. So you can see that x is 3 to the exponent 1. It means you can go to this equation where you see x, you put 3 to the exponent 1, or you can go to equation 2 where you say y equals to minus x plus 1, where you see x, you put 3 to the, yeah, let's do this. So we're going to say y equals to minus, what is x? 3 to the exponent 1. 3 to the exponent y plus 1. So this is after substituting this one in here. So now, if you take 3 to the exponent y to this side, it becomes 3 to the exponent y equals to, if you take y to the other side, it becomes 1 minus 1. So what is the value of y here? Not so easy to spot that y it is 0. Because if we substitute y with 0, we see that the left-hand side is equal to the right-hand side. I think here's my experience that tells me that y it is 0. If you are merely a grade 12 student, it's going to be tough for you here. Y it is 0. How can I find x? You go to any of the equation, you substitute y with 0. You'll see that x is 1. So this is a very cruel question, 5.6. The coordinates there of the point of intersection is 1 and 0. I'm going to stop here. This question 5 was one of the very useful questions. I think if you go through this video of mine, study it very well. Don't be impatient. Go through this idea several times. You should be able to do well in your maths. I see your maths improving. I see you climbing very high in your mathematical knowledge. To God be the glory. Thank you so much. I'll see you next time. I'm going to end my show and end the lesson.